Okay, let's take a look at the graphs of basic square root and cube root functions. And before we get into that, let me remind you of each of these. Um, let's look at some basic square roots. So the square root of 4 is 2 because 2 times 2 equals 4. The square root of 9 is 3 because 3 times 3 equals 9. The square root of 1 is 1 because 1 times 1 equals 1. The square root of 0 is 0. A lot of people don't realize that because 0 times itself is 0. And the key to this on all of these is you need 2. You need to multiply something by itself 2 times. Okay, for square roots. And you could, this list goes on and on. The square root of 16, the square root of 25. Okay, and then let's look at cube roots now to get a handle on those. If I have the cube root of 8, that is 2 because 2 times itself 3 times is 8. The cube root of 1 is 1 because 1 times itself 3 times is 1. The cube root of 27 is 3 because 3 times itself 3 times is 27. The cube root of negative 8 is a little different now, is negative 2 because negative 2 times negative 2 times negative 2 is negative 8. And so you can also have negatives with your cube roots. If I try to do that over here, the square root of negative 4, you can't. 2 times 2 is positive 4. Negative 2 times negative 2 is also positive 4. There's no way to get the negative 4. So over here we can't do square roots of negatives, but you can do cube roots of negatives. So that's important before we start looking at these graphs. So let's start with the basic square root function. Should be pretty easy now. The basic square root function f of x equals the square root of x. Well, that's the same as the equation y equals the square root of x. And if we were to set up this table, we have to be kind of careful about the x values we choose. We already know that x can't be a negative number here, right? So we can't choose negatives. So the first value we could choose that's not negative is 0. Okay? And then we could choose numbers, any number bigger than 0, 1, 2, 3, etc. But let's be smart about this. What numbers would be easy to put in here for x to take the square root of? Well, how about 1 and 4 and 9 and 16 and 25, right? Etc. I could keep going. Now there's numbers between those, but these are the easy ones to take the square root of, and I'm trying to avoid using a calculator. Okay, so let's get to it. Y is the square root of your x value for this equation. So if x is 0, y is the square root of 0, which we already saw is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Let's see what that looks like on a graph. So we will start with the ordered pair 0, 0. That's what this represents, which is the origin here. Then I'll move to the right. Notice there's not going to be anything, no graph on the left side because I can't use negative x values. My domain is going to be numbers 0 and bigger. My x values will be numbers 0 and bigger. Okay, if I use the ordered pair 1, 1, that goes here. So if x is 1, y is 1. If x is 4, y is 2. That's because the square root of 4 is 2. The y values are the square roots of the x values. The next x value I have is 9. The square root of 9 is 3. Then I go out. The square root of 16, which is way over here, is 4. The square root of 25, which is even further, is 5. And so what's happening is your x values are getting further apart. And so your graph, as you move to the right, is flattening out. It's growing as you move to the right, but it's slowing down, okay? And that is your square root function. It's kind of strange. It just stops. Now, what I want to caution you of is most people forget about this guy, 0. And so a lot of people will stop right here and leave this region of the graph off. Don't forget this region, okay? So this is this horizontal sort of curve, and that's your square root function, your basic square root graph. Let's look at the cube root function. With cube roots, we can have negative numbers under the root. So this is the same as the equation y equals the cube root of x, and if I set up my table of values, it's going to be rather extensive actually. 0 is not going to be my first one, it's going to be in the middle of the graph, and then I'll look at negative x values and positive x values. Now, what types of numbers do I want to put under a cube root? Well, things that are easy to take the cube root of, like 1, 8, 27, the ones we talked about earlier, but also negative 1, negative 8, negative 27. I can easily take the cube roots of these numbers. The cube root of negative 27, because that's how you calculate the y values in this formula, is negative 3. The cube root of negative 8 is negative 2. Cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. Cube root of 27 is 3. Let's see what that looks like on a graph. And you may recognize you have a pattern here, right? You've got your 0, 0 right in the middle. So let's go ahead and plot that. 0, 0 is right there. And then on each side, your y values are similar as you work out from your 0, except instead of 1 and 1, one of those is negative 1, the other is positive 1. Instead of positive 2 and positive 2, you get negative 2 and positive 2, and negative 3 and positive 3. Okay, so let's move to the right and understand what happens as I move to the right. If x is 1, y is 1. If x is 8, y is the cube root of 8, which is 2. If x is way over here at 27 off the screen, y is 3. So this graph, similar to the square root function, it's a curve getting flat even faster than the square root function. Okay? But now the difference is we have a left side of this graph. We can use negative x values. If x is negative 1, y is negative 1. If x is negative 8, y is negative 2. If x is negative 27 way over here, y is negative 3. So it's the same behavior, it's just in the negative direction. And that's what this symmetry is talking about here. You get the same values, but on one side the values are positive, and on the other side the values are negative. And that is your cube root function. The big difference is here you can use negative and positive x values. And 0, of course. But up here, no negative x values on the square root function. So this graph is somewhat unique because it just stops. It comes to this abrupt stop right here. Whereas this graph is nice and smooth and continuous and just keeps going.